Did you know that the debate over who the first Americans were has lasted more than a century? For decades, the dominant theory was that it all began with a narrow strip of land connecting Siberia and Alaska, the Bering Bridge, where mammoth hunters made their way into the New World. They became known as the Clovis people, and for a long time, archaeologists believed they were the very first. But recent breakthroughs in DNA analysis have upended that belief. From ancient bones unearthed in Alaska, Siberia, and even South America, scientists have managed to extract entire genomes, and what they found completely changed the story. People arrived much earlier than we thought, came by different routes, and descended from different ancestral groups. Some lived for generations in the frozen expanse of Beringia, while others traveled by boat along the Pacific coastline, bypassing the icy mountains. Thanks to genetics, we can now trace this incredible journey, step by step, from the shores of Lake Baikal all the way to southern Chile, and see that the first Americans weren't who we thought they were. All throughout the 20th century, scientists believed that America's human history began around 13,000 years ago. That was during the height of the last ice age, when sea levels dropped dramatically and a vast plain called Beringia emerged between what is now eastern Russia and Alaska. It was a land bridge wide enough for animals and people to cross. According to the classic theory, hunting groups from Siberia followed herds of bison and mammoths across that land. When the climate warmed and the glaciers began to melt, they pushed further south through a narrow corridor between two massive ice sheets, the Mackenzie and the Laurentide. Then, in 1929, near the town of Clovis in New Mexico, workers discovered ancient stone spear points next to the bones of mammoths. Radiocarbon dating didn't exist yet, but it soon became clear the find was over 13,000 years old. These hunters were named after the site, the Clovis culture. Their tools have been found across the United States, from Texas to Pennsylvania. The sharp, masterfully crafted spear points were seen as proof of advanced technology and a single, widespread migration. For decades, the Clovis people were considered the first to set foot in the New World. Textbooks and scientific journals described just one version of events: a land migration from Siberia, a journey through the ice-free corridor, and then a slow spread southward. It all seemed to line up. The land bridge was there, the weapons were real, and the timing matched. America was thought to be the last continent humans settled, and that settlement was relatively recent. But as more archaeological evidence came in, cracks began to form in that theory. In Chile, at a site called Monte Verde, archaeologists found signs of human life nearly 14,500 years old. In the Yukon, there's evidence of hunting dating back over 15,000 years. And in Oregon, human footprints and DNA samples have been dated to more than 14,000 years ago. Those numbers didn't fit the old story. It now seemed clear. People were already living in the Americas before the glaciers melted and the ice corridor even opened up, meaning they had to have arrived by a different path. The scientific community didn't accept the new findings right away. The old explanation had held strong for decades. It was simple and seemed convincing. But each new discovery added another layer of doubt. It became clear that the American continent had been inhabited earlier than the Clovis first model had suggested. That forced scientists to rethink not just the timeline, but the direction of migration itself. And then genetics entered the picture, and delivered an answer no one saw coming. Once the first doubts surfaced, a long period of debate began. The old theory still appeared in school textbooks, but within the scientific community, a major shift was underway. At conferences in the late 1990s, researchers began sharing evidence that didn't fit the established model, and each new paper added pressure to the traditional view. The biggest challenge was methodology. Many of the early discoveries had been documented decades earlier, often without precise locations or preserved samples for follow-up testing. That meant scientists had to return to the same regions and collect new material from scratch. New technologies started to transform archaeology. Microscopic wear analysis made it possible to tell the difference between hunting tools and random stone fragments. Radiocarbon dating began to use calibration curves based on ice cores and marine sediments. For the first time, it became possible to match the ages of different layers of Earth across enormous distances, from Alaska all the way down to Tierra del Fuego. These new checks confirmed what earlier estimates had missed. Humans had been in the Americas longer than anyone had thought. At the same time, a shift in scientific approach was taking place. Researchers stopped searching for a single first culture and instead started studying multiple regional development lines. By comparing stone tool techniques, housing styles, and hunting methods, it became clear that distinct traditions existed in different regions, traditions that weren't directly connected. It gradually became obvious that the story of how people populated the Americas was far too complex for one tidy explanation. That raised a new question. Who was responsible for these differences, and where had the original population come from? The answer, once again, came from genetics. As archaeological data stopped fitting the old framework, scientists turned to DNA. In the 2010s, researchers developed techniques for extracting DNA from bones that had been buried for tens of thousands of years. The first full genomes of ancient Americans came from the remains of children found at the Anzac I site in Montana and Upward Sun River in Alaska. They dated back around 12,000 and 11,000 years. When these samples were compared with ancient Siberian remains, like those from the Malta Bure site near Lake Baikal, a direct genetic link emerged. The people who crossed through Beringia were descended from ancient North Eurasians who had lived in Siberia some 24,000 years ago. Later, their descendants mixed with East Asian groups, and that blend gave rise to the first Americans. The genetic data confirmed it. The connection between Asia and the Americas had been established long before the glaciers melted. Some groups may have lived for thousands of years on the Beringian land shelf, isolated from both continents. These were the ancestors of all indigenous peoples in the New World. Their genetic legacy is still present today, from the Inuit of Alaska to indigenous peoples deep in the Amazon. The latest breakthroughs in genetics have completely reshaped how we understand the migration routes into the Americas. For a long time, the dominant theory was that people moved from Siberia across the Bering Bridge and then traveled south through an inland, ice-free corridor. But ancient DNA studies, published in Nature and Cell in 2023, revealed a much more complex picture. The ancestors of Native Americans didn't just come from Siberian hunters, they also descended from populations along the northern coast of China and the Russian Far East, dating back around 26,000 years. Their descendants spread along the Pacific coastline, following rich coastal environments filled with fish and shellfish. At that time, the ice corridor was closed off, and the only viable path was by sea. The genetic trail of these early people is clearly visible through mitochondrial DNA. Researchers have identified 4 primary maternal lineages in indigenous peoples across North and South America. There's also a rare 5th lineage, still found among some Native American tribes in the north, tracing back to ancient groups from East Asia. The match between these DNA markers and ancient remains from northern China and the Amur River region makes it clear. It was along the Pacific coastlines of Asia that the population emerged which would eventually give rise to the peoples of the New World. This genetic evidence helps explain why early traces of human presence appear along the coastline, from Alaska all the way to Patagonia. These people didn't move through glacial terrain, but traveled along the ocean, likely using simple boats or rafts, stopping on islands and coastal sites. The journey may have taken centuries, but it was consistent and relatively safe. Migration happened in slow waves, and each one left a mark in the DNA. That's why the genetic map of the Americas today looks like a mosaic, reflecting both the heritage of ancient Siberian groups and the coastal populations of East Asia. As researchers began comparing ancient genomes from around the world, they discovered the story of the first Americans was even more intricate. DNA from early American populations carried fragments inherited from Denisovans, an archaic human species that lived in Asia over 40,000 years ago. These same traces are found in present-day peoples of Tibet and Melanesia. That means some of the genetic legacy of the first Americans originated long before their ancestors ever left Eurasia. Another striking discovery came from South America. Among certain indigenous groups in the Amazon, scientists found shared DNA segments with Aboriginal Australians and people from Papua New Guinea. This has been termed a ghost lineage, found in some of the earliest inhabitants of the Americas. It suggests that there may have been additional, much earlier migrations along the Pacific coast, long before the main wave that brought the ancestors of the Clovis culture. Findings like these have transformed how we understand human movement in the late Pleistocene. The Americas weren't settled by a single group, but by people who already carried the genetic imprint of ancient mixtures from across Asia. Their DNA blended Northern Eurasian, East Asian, and even South Asian elements. Some of these lineages disappeared over time, while others spread across the continent. This genetic complexity helps explain the wide range of physical traits and biological diversity seen among Native American peoples today. What genetics has shown is that the story of the New World didn't begin from scratch. It was a continuation of a much older Eurasian saga, carried forward across ice and ocean. A combination of genetic, archaeological, and linguistic evidence has completely reshaped our understanding of America's ancient past. It's now clear that its earliest inhabitants didn't descend from a single ancestral line, but were the result of layered migrations and interactions that unfolded over tens of thousands of years. In the DNA of modern indigenous peoples, scientists have found traces of both ancient North Eurasian and East Asian populations, along with rare genetic signatures found nowhere else on Earth. These unique markers tell us that the story of America didn't begin with a single migration, but with the long formation of a distinct and self-sustaining world, one that developed independently from the Old World. Thanks to new methods in isotope analysis and paleogenomics, researchers can now trace how ancient peoples adapted to a wide range of ecosystems, from Arctic tundras to tropical rainforests. Differences in diet, tools, and settlement patterns confirm that by as early as the 12th millennium BCE, culturally distinct and regionally rooted societies had already emerged. This isn't just the start of civilization, it's a separate chapter in human evolution. These discoveries have forced scientists to rethink the very framework we use to understand the past. America is no longer seen as the final stop in the spread of Homo sapiens. It's now recognized as a parallel stage where its own branches of humanity evolved and thrived. The new picture doesn't show a single path of migration. It reveals a web of ancient worlds, connected through genetic memory and traces left in the soil.